Alright, I bailed out of that video last time in 10.7 because it took a while to do those first 6 problems, and so we'll finish up those here. So starting with number 15. And starting in number 15, we're still back in the same type of problem here, where we're being asked to find the fourth Taylor polynomial and then write it in sigma notation. So my function here is x sine x, and this could get messy. Taking the derivative of this, I have to use the product rule. So let's see. And if that's news to you now, I would pause right now and say, oh, whoops, got to use the product rule, right? Not optional. Derivative of the first is 1 times the second plus the first times the derivative of the second. Second derivative of sine is cosine, plus, and then I have to use the product rule on this. So the derivative of the first is 1 times the first plus the first times the derivative of the second, which is minus x sine x, right? Because the derivative of cosine is negative sine. And for the purposes of taking derivatives, I think I better simplify that now. And the third derivative is, let's see, the derivative of 2 cosine x is negative 2 sine x, and then minus product rule on x sine x. I just did that. That's this. That's sine x plus x cosine x. And again, for the purposes of taking the next derivative, I'm going to simplify. Minus 2 sine x minus another sine x is minus 3 sine x minus x cosine x. And then the last one, I have let's see, the derivative of minus 3 sine x is minus 3 cosine x minus the derivative of x cosine x. I just did that here, right? So that's minus this thing. So it's minus cosine x minus x sine x. Trying to recycle as much as I can. So let's see, I have minus 4 cosine x plus x sine x. So there is a pattern going on here, but it's kind of a complicated pattern. And what are all these things equal to at x equals 0? Here, 0, right? All the things that are times x are going to be 0. Here, sine x is 0, and that's got a 0 right in front of it, so that's also 0. Here, oh, sorry, I'm going to do it here, my simplified version. That's going to be 0. 2 cosine x, cosine of 0 is 1, so finally I get a non-zero term there. And then here, that's 0, and so is that. And here, minus 4, and that's 0. So all that work, and I just got 2 non-zero terms, 2 and negative 4. So let's cook it up. The constant term is 0. The first degree term is 0. When I get to the second degree term, I have 2 times x squared over 2 factorial. The third degree term is 0. And the fourth degree term, minus 4 times x to the fourth over 4 factorial. And I'm going to simplify that for the purposes of trying to write it in sigma notation. So that's just x squared minus, and then the 4 is going to take off the 4 of that factorial and make it x to the fourth over 3 factorial. It might be kind of hard to imagine what the pattern is here, and I know they didn't ask us to, but if they had asked us to go further, the next term you might imagine the next term that shows up is this, right? Even, even, even. So that would be here, that would look like, when we simplify it, x to the 6th over 5 factorial. Maybe just having one more term might help us figure out what this is going to look like. So I've got x to the even number, and that's going to be 2k. And then on the bottom, I have a factorial that's 1 less. You can imagine like a 1 factorial under there. That's 1 less than that. So that's 2k minus 1 factorial, right? 1 less than this. And I also have flipping signs. Now, to get it to look like this, what do I want k to start at? It looks like my first term is the x squared term, so I want k to start at 1 to n. And then I want the first term to be positive, so in this case I am going to need a plus 1 there. So that's what that looks like. It's a little bit trickier, that one, I think. Super important skill. We practice. We get better. Number 16, x e to the x. So let's find our derivatives. Product rule again. So derivative of the first times the second plus the first times the derivative of the second. Second derivative. Derivative of e to the x is e to the x plus the derivative of this. Well, I just found the derivative of that. It's this, right? So plus e to the x plus x e to the x. Sorry, that's just a dot there. It doesn't mean anything. And again, for the purposes of taking further derivatives, I'm going to simplify that. Third derivative, derivative of 2e to the x is 2e to the x. Derivative of x e to the x is that same thing. Another e to the x plus x e to the x. So maybe you can see what's happening here. I keep getting a bonus e to the x in front plus x e to the x. And observing that pattern, I'm going to go ahead and say that the next derivative is 4e to the x plus x e to the x. So what are all those equal to at x equals 0? Well, here, when x equals 0, that's just going to be equal to 0. And all of these terms with an x here are going to get knocked down to 0. But this is 1. And this will be 2 times 1 plus 0. This will be 3 times 1. And this will be 4 times 1. So there you go, 0, 1, 2, 3, 4. That's a pattern. So let's cook this thing up. So the fourth Taylor polynomial, the constant term is 0, and then 1 times x, and then 2 times x squared over 2 factorial, is 3 times x cubed over 3 factorial, 4 times x to the 4th over 4 factorial. Right? So these things are always given, right? Those are always the same, it's just the coefficients that are different. Alright, so I'm going to simplify that for the purposes of trying to see what's going on here. 2's cancel. The 3 cancels with the front 3 here, and that gives me x cubed over 2 factorial. The 4 knocks the front 4 off that, so it's x to the 4th over 3 factorial. And you could think of these if you wanted to. That's like 1 factorial, and this could be like a 0 factorial on the bottom, which is also equal to 1. So sigma notation. K equals, let's see, it looks like I have x to the k, and then I'm dividing by the k minus 1 factorial. 1 factorial less than what the power is. And I would like to start with a power of 1 on the x here. So I'd like to start k at 1. And 1 minus 1, 0 factorial, that's okay, that's just 1. So that's good. number 17. 17, 20, and 22. Can we fit? I bet we can fit 17 in here. Now the difference here is that we are making, actually, you know what? I'm going to do it on the next page because I want to rewrite at the top. Remember that the Taylor polynomial at x equals x sub 0, not at 0 this time. So now we're going to make a couple series not at x equals 0. That changes our recipe a little bit. So now our Taylor polynomial, our nth one, looks like f of x sub 0 plus f prime of x sub 0. And now instead of times x, it's x minus x sub 0. It's like that factor that goes with this. And then f double prime x sub 0 times x minus x sub 0 squared over 2 factorial. So everywhere where we had x's in the last round here, now we have x minus x sub 0's. And if you wanted to go up to the nth one, you would have to take the nth derivative at x sub 0 to x minus x sub 0 to the n power over n factorial. It's the same thing, except instead of, well, put it this way. If you plugged in 0 everywhere for x sub 0, you'd get the Maclaurin polynomial, like we did in all of the previous problems so far from this section. But if it ain't 0, then this is what it looks like. All right, and a little practice will hopefully help us out here. So sorry, this is not 15. We're doing what, 17 now? 17. Okay, so doing it for e to the x. So that's super easy for derivatives. F of x is equal to e to the x. And so is the first derivative. And so is the second derivative. And so is the third derivative. And so is the fourth derivative. I can say it faster than I can write it. That's my superpower. And then at x equals, what are we doing now? X sub 0 equals 1. This is equal to e, and 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 this is equal to e. How? Let's try this recipe. So what's f of x sub 0? It's e, right? I still have all the numbers that I need here. That's still all my coefficients, just that these are going to look a little different now. So plus f prime x sub 0 is equal to e times x minus 1, right? All my x sub 0's are 1. And then f prime is also e times x minus 1 squared over 2 factorial plus e times x minus 1 cubed over 3 factorial plus e times x minus 1 to the 4th over 4 factorial. That's it. So, in summation notation, from k equals I don't know what to n, looks like I have e every time, and then I have x minus 1 increasing in power, so to the k power over the k factorial, and signs are not alternating. I would like to start with just an e, so that's when that would be equal to 0. So there you go. And number 20, and then 22, is that right? Yeah, 20 and 22. So number 20, we have f of x is equal to 1 over x plus 2. And for the purposes of taking derivatives, I'm going to write it like that. So my first derivative is negative x plus 2, negative 2. Second derivative is 2. So this kind of feels familiar, right? We've done one like this. Negative 6, which is the same as, it's 3 times 2, so I think I know where this is going, right, with factorials. And then the fourth derivative is 4 factorial times x plus 2 to the negative 5th. And here we're finding the polynomial, the Taylor polynomial at x equals 3. And I'm going to say x sub 0 equals 3. So here, plugging that in here, that is, when I plug 3 in there, that's 1/5. When I plug 3 in here, that's negative 1 over 25. When I plug the 3 in here, it's 2 over 5 cubed. When I plug the 3 in here, it's negative 3 factorial over 5 to the 4th. I'm leaving these as 5 to the whatever because I think that's going to make it easier to write out, and definitely when I get to sigma notation that's going to make it easier. 4 factorial over 5 to the 5th. All right, let's cook it up. First term, 1/5, minus 1 over 5 squared times x. Times x minus x sub 0 plus coefficient times x minus 3 to the 2 over 2 factorial plus coefficient, this is a minus now, 3 factorial over 5 to the 4th times, this is the third one, so x minus 3 to the 3rd over 3 factorial plus 4 factorial over 5 to the 5th times x minus 3 to the 4th over 4 factorial. Right, so there's a lot of bits to keep track of there. But it's still coefficient times second term, coefficient times third term. So these x's are now those factors, x minus x sub 0. That looks like it wants to be simplified sum. So I have 1 over 5 minus x minus 3 over 5 squared plus the 2's cancel, x minus 3 squared over 5 cubed minus 3 factorials cancel, x minus 3 cubed over 5 to the 4th plus x minus 3 to the 4th over 5 to the 5th. Okay. Sigma notation. Looks like I have x minus 3 to increasing powers, right? Just 1, 2, 3, 4, not even or odd, just every power. So that's x minus 3 to the k. My signs are flipping, so I need a sign flipper. In the bottom, whatever power this is, I have 5 to 1 bigger than that. So that's 5 to the, if that's k, then this has to be k plus 1. Now, the first power of these that shows up is 0, right? The first time I want no x minus 3's to show up. So I'm going to start at 0, and we can just check to make sure that works. And if that's 0, that'll give me a first positive term. So there's my sigma notation. I would like you to think about this. This is actually a geometric series. I'd like you to look at that, think about what the multiplier is, and then if you wrote out the sum of a geometric series, what that would be equal to in this case, and what that has to do with the original problem. No, seriously, I want you to do that. So pause the video and think about that for a second. Thinking, right? It's good. It's not just about finishing the homework assignment. Think about it. No, seriously, pause the video and think about that. Here's the first term. What's the multiplier? Write out sum of geometric series and see what it looks like, and look back at the original problem. Okay, you're back. Last one, number 22. We're going to do the cosine function. We're going to do the series at x sub 0 equals pi over 2. So cosine x, derivative is negative sine x. Second derivative is negative cosine x. Third derivative is sine x. Fourth derivative, back to cosine x. And I want to know what all these things are equal to at x sub 0 equals pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. 0 again, positive 1, and 0 again. Alright, so I'm going to cook this thing up. The first term is 0. The first degree term has a coefficient of negative 1 times x minus pi over 2 to the first power over 1 factorial, if you want to think about it that way. Second degree term is knocked out by that 0. Third degree term plus 1 times x minus pi over 2 to the third power over 3 factorial. So don't have much to work with there. See if we can get the sigma notation from that. K equals something to n. So it looks like I have x minus pi over 2 to odd powers, and we get odd numbers by doing 2k plus 1. And whatever that 2k plus 1 is 1 or 3, I'm dividing by that same factorial, 2k plus 1 factorial. And I have a sign flipper. So it looks like I want to start with the one where it's first term. So if I use 2k plus 1, I would need a 0 here to get a 1 to show up. So I'm going to start at 0, right? Not because I want that to be 0, because 2k plus 1, I need that to be 0. And if I start there, that's going to give me a positive first term, but I want a negative first term, so I need to do that. And that is what that looks like. So, it's messy to do it this way. There will be shortcuts for these things, but at the end of the day, we really need to be able to cook up series from scratch. We will have other ways of making these series, and everything that we've done so far here in section 10.7, we are making these series from the actual recipes for the series, whether it's a proper Taylor series or a so-called Maclaurin series where we're doing it at 0. We are making these series from scratch, and sometimes that is just what you have to do. So we need to know how to do it.